Hello and welcome to section 1.3. So this is a section where we actually get the math tied in and everything pulled together as far as how we also present our data for our labs and scientific information. So we're going to look first at graphs. Now we have three types. We have a line graph, a bar graph, and a pie. Okay, so let's look at how we'd use each one. Line graphs are going to compare changes. Okay, so changes in your data. Most of your graphs in science are going to be line graphs. The second one is a bar graph. Now this compares data together. And the third one is the pie. Now this represents something as a whole. Now in your social sciences, like psychology, you might use more of the pie charts. Okay, so these are your three choices for graphs to show your data. Graphs are an easy way for scientists and others that are not scientists to see data instead of trying to read it through a paragraph. All right, so let's look at how you really need to represent your line graph. Okay, you have a y and an x value. Now, on the x-axis, you will have the independent variable. Now this is the variable that does not depend on the experiment. So time. Time keeps going. It's not dependent on the experiment. So time is something you put on the x-axis. Now the y-axis is the dependent variable. Now with the dependent variable, that is totally dependent on what's going on. So something like distance might go on the y-axis. Okay, because your distance can change according to the experiment, whereas time will keep going. All right, now, one thing that a lot of people forget to put on their graphs are actually titles. So you want a title that kind of explains what's going on in your graph. And that's just a simple review of graphing. We will do more graphing exercises in class. The next thing I want to move on to is accuracy and precision. So let's look at both and why they're different from each other. The accuracy is actually when you're close to the value. So if you're shooting darts and you're close to the bullseye with all your shots, that would be accuracy. Okay. Now, the difference with precision is it does not have to be close to the bullseye, but your darts need to be close together. Okay, so you're not close to the value, but your answers are close together. Okay, and that is the difference between accuracy and precision. So, if I were to ask you how could you be accurate when shooting darts, you could simply say, all my darts are near the bullseye. If I were to ask you how you could be precise when shooting darts, your answer would be, my darts are not close to the bullseye, but all my darts are close together. Okay, so that's the difference between these two. Now, the last thing in this section is significant figures and writing in scientific notation. Now, I love writing in scientific notation. It's faster, and I'm not counting out zeros. So we are going to practice writing in scientific notation. And we will do this practice in class so that I know that everybody's doing well with it. Plus, we have significant figures. Now, this is going to be a concept that is new to you. Most of you at one point in time have raised your hand and asked the teacher, to what value do I round? Now, we are going to do some simple rules in class on significant figures so that there is no longer a question to what place do you round to. So think of significant figures as not only showing how accurate the answer is, but also showing the rounding rules. Okay? And this is short and sweet. We will do a lot of this in class. And thank you for watching. I hope things are going well with your Cornell notes.